In 9.4, we're going to be dealing with all the shapes that you learned about in 9.1, 9.2, and 9.3. So right now, I believe that there's like 6 different shapes that we've talked about. You found their areas, you found their perimeters. Some of them are called circumference, some of them are called, are dealing with other things. But the first thing that you're going to need to know is something that you've learned in junior high school, but let's just talk about it, is the 3 different ways to classify a triangle. How to classify triangles. How to classify triangles. There are 3 different kinds. I bet you know what they are. First one is called scalene. The second one is called isosceles. The third one is called equilateral. So, if I have a scalene triangle, by the way, how many of you have actually heard of scalene, isosceles, equilateral already? Okay, very good. So then I'm not saying anything new to you. Scalene's when there's 3 different sides. It looks like this. 1, 2, 3. All sides are different. Isosceles, 2 sides are congruent. Dun, dun. When 2 sides are the same, it's called isosceles. And equilateral, 3 sides are congruent. 1, 2, 3. The awesome thing is that we've actually constructed an equilateral triangle already. We did that in Unit 8 when we were doing constructions. Okay, so you will have problems like this on number 4 where you are going to be asked to classify whether a triangle is equilateral, whether it's scalene, or whether it's isosceles. And here is the hardest part about it. And so I want to show you an example that looks like number 1. On number 1, we have a point at -2, 0, right here. We have another point at 4, 2. 1, 2, 3, 4. 1, 2. We have another point over here at 2, -2. And then it has this triangle drawn like this. The directions are going to say classify as scalene, isosceles, I'll abbreviate that, or and I'm going to abbreviate that. Classify as scalene, isosceles, or equilateral. So when you're looking at this, do not base your choice off of how it looks. If I go off of how it looks, I might choose scalene because it looks scalene. It looks like all 3 sides are different. But how could I know for sure? We're going to have to use Pythagorean Theorem. Now, when I choose to use Pythagorean Theorem, what I'm going to do is I'm going to do a simplified version of the Pythagorean Theorem. Watch what I do, and I want you to see it. If I want to know how long this side is, let me do this yellow side real quick. I'm going to highlight this side in yellow, okay? Let me zoom in just a little bit so you can really get an idea of what I'm doing. Okay, I don't know how long this is because it's on a diagonal. But what I can do is this. I know that I can draw a dotted line down, dot, 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 straight down the line to here, and then dot, dot, dot over here. You good with that? What I know about this yellow side is that a squared, let's call this side is a distance of 2, plus b squared, 1, 2, 3, 4 is a distance of 4. A squared plus b squared should equal c squared. And so this is what I think about that yellow side. 2 squared plus 4 squared should equal this yellow side squared. Do you agree with me on that? Yes? Okay, don't work it out. Leave it like that. That's as much work as you need to do for that yellow side. Now, I don't know if this yellow side, I don't know if that's the same as the other sides or not. But what I can do now is I'm going to switch colors on my pen, and I'm going to go figure out, I'm going to call this side the orange side. Okay? You good with that? Now for the orange side, I'm going to also draw a right triangle outside, and I'm going to count over this way. And I know it goes down 2 units here, 2 units there. And then how far over does it go? It goes 1, 2, 3, 4. Do you agree with that? When we count it over, 1, 2, 3, 4. It's under 2, comma, negative 2. So what I know right off the bat is this. A squared plus b squared should equal the c squared. A squared plus b squared should equal the orange side squared. Now look at those two equations. Is the yellow side going to mathematically be the same as the orange side? Yes. They have to be. You don't even have to do the math here. You don't have to square the 2 or square the 4, put it together and square root it to find out how far it is. You know, because these two equations are the same, that they are going to be mathematically accurate. By the way, it would have worked the same if I had 4 squared plus 2 squared equals the orange squared. You would still know those are the same thing. So I know these two sides are congruent to each other. Now about this other side, if I want to figure out what this other side is, just to see, well, now I know it's isosceles, but is it equilateral? Let's check. Here's the pink side. I'm going to count up. It's up 2. Ooh, that's close. Let's count over. 1, 2, 3, 4, 5, 6. Is that pink side the same as the orange side and the yellow side? So what kind of triangle is this? That's our final answer. Our final answer is that it is isosceles. And that's how I expect you to check all of these things. You are going to have to look at the side lengths. How long is it? Because a lot of these are diagonals. A lot of these are diagonals, and that's what you're going to do. And you're going to do this for numbers 1 through 4. Numbers 1 through 4. Okie dokie. Okay, that brings us to the next type of thing, the types of quadrilaterals. Types of quadrilaterals. We have this whole gigantic flow chart for you for quadrilaterals that is on the backside of your check sheets. So check sheet, right? If you were to turn that check sheet over, you have this gigantic flow chart that talks about four-sided shapes. So a quadrilateral is any polygon with four sides. If it has four sides, it's called a quadrilateral. There are three different ones that we're covering here: parallelograms, trapezoids, and kites. So I'm going to write that. Types of quadrilaterals. There are parallelograms, parallelograms. I'm going to draw a picture for you. Trapezoids. I'm going to draw a trapezoid for you. They have a second base. And kites. There are other kind of quadrilaterals, but these are the specific ones that we are going to talk about. Parallelograms, trapezoids, and kites. I'm going to highlight these three things, I'm sorry. A parallelogram is a quadrilateral. A quadrilateral is not necessarily a parallelogram because it could be a trapezoid or it could be a kite. Now, as a part of this flow chart, what is a parallelogram? There are different types of parallelograms. There's two different types of parallelograms. I'm going to draw an arrow this way and an arrow this way. There's a rhombus and there's a rectangle. There's a rhombus. All four sides are the same. And then there's a rectangle, which has two pairs of opposite sides that are congruent with four right angles. A rhombus and a rectangle is a parallelogram. And lastly, there's this thing that is a rhombus and is a square. Is a rhombus and a rectangle. It's called a square. Four sides that are the same and four right angles. So we have three different types of quadrilaterals. We have parallelograms, trapezoids, and kites. Those are the main classifications. These are a rectangle is always a parallelogram. A square is always a rectangle. A square is always a rhombus. A rhombus is always a parallelogram, and so on. So these are what you're going to have to classify some of the shapes in numbers 5 through 8. So your job really is to figure out, when you look at these particular graphs, is it a rhombus? Is it a square? Is it a rectangle? How do you know? The biggest way you're going to know whether something is the same or not is similar to this. How did I know if the sides were the same? You had to use the Pythagorean Theorem. But don't work it out. Just do this outside stuff and figure out how far Are those the same as each other? Make these triangles to figure out whether the distances are the same. That's what we're going to be doing down here with these types of problems. The other way you're going to need to know to figure it out is if these angles are right angles, then you're going to know it's a rectangle versus a rhombus or a regular parallelogram. So how do we know that? I'm going to write a little note to you right here onto the side. If the slopes of the segments are negative, and I'm going to put in parentheses opposite reciprocals, then they are perpendicular. If the slopes of the segments are opposite reciprocals, or negative reciprocals, then they are perpendicular. So here's how it works. I'm going to give you an example that looks like number 5. Number 5 looks like this. It has a graph for you. It has a point at negative 3, 1. 1, 2, 3, 1, negative 3, 1. That's letter D. Then it has a point for you at 0, 3. That's point A. 2, 3, 0, 3. That is point A. Then it has a point at 3, 0. 1, 2, 3, 0. And that is point B. And then point C is at 0, negative 2. I'm going to connect these dots to try to be as accurate as possible. It's hard when you're looking at these things. You'll have a little guess in your mind, what shape is this? It's going to say, use the most precise classification of the quadrilateral. So classify the quadrilateral. That's what it's going to say. That's the directions. And we want the most accurate name possible. So you're looking at this, you might think, well, that doesn't look like a trapezoid to me. It doesn't look like a kite. You're either good. Is it a parallelogram? Is it a rhombus? Is it a rectangle? Is it a square? That's what you have to decide. Well, how do you know? You have to have certain characteristics. Well, if it's a parallelogram, it could look like this. If it's a rhombus, all 4 sides have to be the same. Let's see. Let's see if this side is the same as this side. How can we figure it out? We're going to do exactly what we did before. We highlight this. Let's call this the orange side. And then we start counting over and make these little triangles. 1, 2, 3. I go 3 over this way. And down 3 over. So I have a 3, 3. And then the orange side I know is 3 squared plus 3 squared equals the orange side squared. A squared plus B squared equals C squared. Right? I don't have to work it out. All I have to do is set it up to know whether this orange side is going to be the same as this yellow side. Okay? Well, how can I figure out how long the yellow side is? You draw this little triangle. And you count. How far down is it for this yellow triangle? How far down is this side? 2. How far over is this yellow side? And then now you can check. 2 squared plus 3 squared equals the yellow side squared. Now look at these two equations. Are those two distances the same? So it cannot be a rhombus because these two sides are not the same. It might be a rectangle still. And since it's not a rhombus, I know it's not a square. It can't be a square, it can't be a rhombus. It's either a parallelogram or a rectangle at this point. Right? I should check this side, but I have a feeling it's going to be a 3 squared by 3 squared. Let's check. 1. Let me just draw this down and draw this over. Is it a 3 by 3? It is. What does that mean? That means that it's the same as this orange side. Agreed? So now my question is it just a parallelogram or is it a rectangle? What is different about a rectangle than a parallelogram? It has right angles with it. How can I check to see if these are right angles? We need to check to see if they are perpendicular. Here's that word, perpendicular. I need to check their slopes. So here's what I'm going to check. What's the rise over the run of this AB? I'm going to find the slope of AB. Instead of rising, it goes down 3 over 3. Negative 3 over 3. What's the slope of this when I simplify it? Negative 1. You agree? Now what about the slope of the yellow one? Let's call that the slope of BC. It rises how much? What's the run? I hope you know that it's a rise of 2 and the slope is 3. So now my question to you is, are these negative reciprocals? If this is 2 over 3, is that negative 3 over 2? Or if this is negative 1, is that a positive 1? Are they opposite reciprocals? Is this a right angle? That's what I'm trying to figure out. Is that a right angle? I can check to see it if their slopes are opposites. They are not opposites. So therefore, this is not a right angle. Because that's not a right angle, what shape does this have to be? What is the best name for this shape? If you said parallelogram, you are correct. It's not a right angle, and these sides are opposites, and they're the same. If you are stuck on what shape is what shape, let me just remind you, a parallelogram on that flow chart that's there on the back of your check sheets, it tells you it's a quadrilateral with 2 sets of parallel sides. That's all that it is. A rectangle is a parallelogram with 4 right angles. It tells you the definitions on each one in case you need to see it. Okay? That's all I have here for you, and that's where we're going to end your notes.